The dissolving metal reduction of an alkyne. So this is a reaction that starts with a carbon-carbon triple bond, an alkyne. In this case, we have 2-hexyne. And it reacts with an alkali metal, so either sodium metal or lithium metal. So these are reactive metals with one s electron, and this is the metal that is dissolving in this reaction. And then the solvent will be a primary amine solvent. So a primary amine. And this primary amine will act as the solvent, and it is also the source of hydrogen in this reaction. So this is a way to add hydrogen across the triple bond of an alkyne. Unlike the catalytic hydrogenation reactions, this is a way to add hydrogen across the alkyne to get the trans-alkene. So the product for this reaction would be the trans 2-hexene. You do not need to know the mechanism for this reaction. So, although you don't need to know the mechanism, I am going to show it to you quickly here so that you have an idea of what's taking place. So, we start with the hexyne. And the first step involves the metal, either sodium or lithium, dissolving and giving up an electron. So I will use the sodium metal. And so what the sodium metal does is it gives up an s electron to one of the alkene carbon atoms. And the pi bond splits homolytically to give one electron to one carbon and one electron to the other carbon. And so what we form in this step, so we've broken the pi bond and we form a lone pair of electrons on one carbon atom, which has a negative charge, and a lone electron on the other. So I have drawn these on opposite sides of this alkene because that is the most stable arrangement. So this is a radical and an anion. So it is a radical anion. And this radical anion is much more stable if we've got these electrons spread on either side of the alkene. So the trans radical anion is more stable. And it is this stability of the radical anion that leads to the addition being overall trans. So when we form an anion here, this is a really strong base. So what it's going to do is it's going to take a hydrogen from the primary amine solvent. So I will use ammonia. So this will take a hydrogen from the ammonia. So we have added one of the hydrogen atoms, and there should still be a radical on the other side. This radical will accept an electron from another equivalent of the metal. So we will have an electron here being donated in. So now we have one electron, we get one more. We will have another anion form here. And this anion can again take a hydrogen from the ammonia solvent or other primary amine that might be used as a solvent. So we had the one hydrogen that was already added, and here we are going to add a second hydrogen to the opposite face of that alkene, so that we end up overall with a trans addition of hydrogen.